So 1-6 is where we're going to be headed. I'm going to be on page 18 in a minute and do for you number 3. There's not really notes for this. It's just putting into use the things that we've been doing all chapter by doing your favorite thing ever, word problem.
Oh my God.
So they are going to have like a paragraph where they'll explain to you something that you will need to draw. Every drawing will be about the same. What's every drawing that you've drawn been of? A triangle. What kind of triangle?
Right triangle.
A right triangle. So if you draw a picture and you don't have a right triangle, something bad happened. We want to make sure we're drawing right triangles. I'm going to do number 3 in a minute, and then I'm going to do number 4 in a minute, and then I'm going to do a couple just made up problems. And that'll be it for this. And then in upcoming days, for tomorrow, after I do 3 and 4, you're going to try to continue on your journey from 5 to 16. Draw a right triangle, do some math with it. If you draw a blank, skip it, go to the next one. They're not like in order of difficulty, so if you have one you can't do, just skip it, go to the next one. But at least try to draw the picture each time. Then we go on a nice long weekend and come back Tuesday. Tuesday we'd be working same page from 17 to 24. 24 is hard, by the way, so don't lose sleep over that one. And then I just gave you a sheet a minute ago. That sheet would be due Wednesday the 9th. So if you want to write on your sheet, do Wednesday the 9th. You could do that at your own pace between now and Wednesday the 9th. And then on Wednesday the 9th, we'll have a discussion where you'll either say, I am so awesome at this, let's take the test on Thursday the 10th. Or more likely, you're going to say, I could use some more work on this, let's do another sheet for Thursday the 10th. And we'll go sheet by sheet and eventually reach a point where we either say, we're awesome at this, take the test. Or we just say, we're as good at this as we're going to be, take the test. But at some point, we just need to take a test. But whether we're reviewing 1 sheet or 2 sheets or 3 sheets or whatever sheets, that's our itinerary for upcoming days. Question about that? Okay, some of the questions are sort of silly. Some of the questions have silly names. Some of them not as silly as others. But on number 3, they say we're going to lean a ladder that is 6.7 meters long up against a wall. It's making an angle of 63 degrees with the level ground, and they want us to decide how high up is the top of the ladder. So what will be one real world thing that's going to be a side of our triangle represented up here once we draw? It's an item we have in our triangle.
63 degrees.
Okay, that's true. I'm going to save that one for last. One of the sides of the triangle.
6.7.
Okay, what is that though?
A leg.
What is it in the real world, in the paragraph?
A ladder.
That is a ladder, okay? So is the ladder going to be completely vertical, completely horizontal, or a diagonal thing? Diagonal. Would it matter if we went this way with the ladder or that way with the ladder? No. Not really, okay? But we need the ladder to be headed diagonally. So I'm going to go that way. There is my ladder. What else do we have, right triangle wise?
A wall.
A wall. How's the wall going to go?
Vertical.
Vertical. So probably something like that. There's my wall.
The ground.
The ground. The ground, we hope, is nice and flat. They said it was level ground. So here is my right triangle. If you want to write on here for yourself, ladder, ground, wall, feel free. But that's not necessary for me. But if that helps you, well, go for it. Go ahead and put that on there. Question about the circumstances? I might try to do something like that even before you start putting numbers on stuff. We did have a 6.7. What was that?
How long the ladder was?
So ladder, 6.7. Then there was an angle. If I wanted to talk about this angle, I would talk about the angle the ladder makes with the ground. How would I know, how could you know, to call this the angle the ladder makes with the ground? Why did I pick those words? Yeah. If I wanted to talk about this, what would I call this? The angle
From the ladder to the wall.
of the ladder with the wall. How did you know to choose those?
Because it doesn't touch the ground.
Yeah, those are the ones that touch. So where the ladder touches the wall is up here. That's the angle the ladder makes with the wall, because those are the touching sides for those words. This is the angle of the ladder with the ground down here. I think that's the one they told us, right?
Yeah, 63.
So 63. And then there's got to be a variable on here somewhere, because there's something that they want us to figure out. Did they ask how high, I think?
Yeah.
Okay, so which would be the how high? The wall. So there's my X. Question about picture draw. Step one, picture draw. I would do probably words and such before I try to do the numbers. Now let's play Oscar games. Okay, so this is the reference angle. So this is the opposite. This is the hypotenuse. I'm not going to label that with an A because who cares? There's no number there. They didn't ask about it. They didn't give it. It's like it doesn't exist for a minute. Which trig word can do H and O? Sum. So we're going to write ourselves a little trig problem, a little trig equation. Sine, cosine, or tangent is always going to be followed by an angle number. What is our angle number here? 63. Always an equals, always a fraction. Just make sure you get the fraction right side up. If we're doing sine, which is the Oscar had, we need to put who over who.
Oh,
Okay, so in the numbers that we have,
X number is 63.
I agree. And that's like phase 2 of your plan. After you get your picture drawn in phase 1, make a trig problem out of what you just drew. A trig word, an angle, an equals, a fraction. Just be careful you're right side up. Okay. Then it's Algebra City. We'd like to get the x alone. X is dividing, so to do the opposite, your job is to multiply. So you can multiply that up right before the trig word and just punch it in just as it would read. 6.7 sine 63. Did it. And I am thinking that should be around 6. Not a bad thing to do either in a story problem. Just think about whether there's enough context there for you to decide if that answer is reasonable or not. If the ladder is 6.7 and the ladder is clearly the longest one, does it make sense that we'd be about 6 in the other direction? I would think so. You know, if that had come up 20, does that have any chance to be right? No. If that came up like 0.2, does it seem like you would use a ladder to rise 0.2? That would also seem sort of nutty. But 6 meters, that's like 18 feet. Yeah, it makes sense to me. Something about 3.
Do you want us to rhyme, or does it matter?
I would usually go 1 or 2 decimal places, but that one is maybe 5.97 might be a better answer.
Okay.
But if you rounded it to the tenths and had 6.0 instead of 6, like I don't care in math whether it's 6.0 or 6.
Okay.
On a homework, not crucial. On a test, I'd have on the directions at the top. I think like on the review sheet, does it say anywhere? Doesn't say, I don't know. On the review sheet, let's go 2 decimal places, just for consistency's sake. A 4 is about the same. Okay, so number 4 is a flagpole problem. We're trying to order a new rope for our flagpole. To find out what length of rope is needed, you observe that the pole casts a shadow 11.6 meters long on the ground. The angle of elevation of the sun is 36 degrees 50 minutes, and they want to know how tall the pole is. On this one, they helped you out by even drawing you the picture. But even if they hadn't drawn you the picture, it's very similar to the last one. You have a flagpole, which has to go straight up and down. There's no real choice there. You had the ground mentioned, so you have a flat thing at the bottom to create a shadow. And then you have the sun kind of coming in diagonally, sort of like this hypotenuse would be like a beam of light. So I'm not labeling it this time, but if you wanted to label what's what with words, we have the ground again. You have a flagpole for the other leg, and the hypotenuse is basically like a beam of light. Numbers, was there an 11.6?
Yes.
What was that?
The shadow on the ground.
Okay, so 11.6 is the shadow on the ground. This angle was 36 degrees and 50 minutes. And then I don't know, what did they want?
How tall the pole is?
How tall the pole is, so there's my X. So phase one picture, there we go. Anybody puzzled by picture drawing? So OA or H? Okay. Okay. What trig word is stuff with A's and O's?
Tangent.
That is tangent. After the trig word, you always put an angle. The only angle you have to work with is 36. So 3650 equals, and then always a fraction. Just make sure your fraction's right side up. Whoever who, based on Oscar's rules. X over 11.6. So phase one, picture. Phase two, trig problem. Phase three, a little bit of algebra. Question about getting that written. So how would you solve for X?
Multiply both sides by 11.6.
Yeah, multiply that 11.6. So we're going to punch in 11.6, tan, 36, and then an uh-oh, because you don't have a way to punch in the 50 minutes. Does anybody have a helpful suggestion of how you can try to take on the 50 minutes? What does the 50 minutes even mean?
Is it like decimals?
Yeah, it's like a decimal. How could we make the appropriate decimal?
36.50?
Disagree.
50 divided by 60?
Correct. So after you have the 36, put a plus and go 50 divided by 60, and then close the parentheses off because you have a lot of stuff in there now. But there's 60 degrees or 60 minutes in a degree. So this is like 50 60ths added on to the 36. So 11.6, tan, start the parentheses for you. 36 plus 50 divided 60, wrap it off at the end. Hit enter, and I'm hoping like 8.69. Here's another reasonability check. We know that the triangle has to always add up to
180.
180. So we already have a 90 out of the way. That leaves another 90. So if this is 36, this is somewhere in the 50s. It doesn't even matter if you figure out exactly what it is. It'd be enough to figure out that that's in the 50s. Do you remember a thing about pairing these off? A truth about their sizes? The bigger angle has to go opposite the bigger side. So if this is in the 50s and it leads us to an 11, something in the 30s leading you to an 8, that seems reasonable. I mean, that's another way you could just check to see, does this seem like it's possible? If this came out bigger, caused by a smaller angle, that would be nuts. It can't happen. Something about those. And here's a what if. So skipping the picture, skipping the background story, just advancing to the point where we've already written the equation down. If I got to a point where I wrote this equation down, this has a different feel to it. Why is this equation different than the two we just did?
X is on the bottom.
X is on the bottom. So if we have to solve for an X that's on the bottom, does anybody have a suggestion?
Can you flip it?
We could, but we create another problem. We did that in physics. In physics, we did some problems where we just flipped everything. Okay, but our problem is if we flip sine, we create cosecant, and you don't have a cosecant button. So we'd rather stay married to sine and not flip it. So that's a good algebra idea, but in a trig problem, that'll fail us. So we need another approach.
Could you like act like the sine 40 was a constant and then like kind of cross.
You could kind of do that, yeah, like this is over a 1. So what I would suggest is you don't want the x on the bottom. So if it's dividing by x and you want to do an opposite, you could multiply by x. So the x is coming up. Then x is with this mess. So to get rid of the mess that x just joined in, the mess would have to go back to the other side. Essentially, these guys can just flip-flop positions. So the x could multiply up, and now it's multiplying this. We have to divide that down. These guys are basically interchangeable. You could also have done like a complete cross multiplication if you wanted to. Like that would have taken you on the same road. But we'd be looking now to punch in 10 dividing sine 40. If you want to punch with me, I'm hoping that what the calculator says is something in the 15.5 range. Around there. Then here's the third place that the x could go. Okay, we did a couple with the x on the top. We did a couple with the x on the bottom. The third thing that could happen is that the x could be over there. Does anybody have a suggestion on what to do about that? So who lives here? That's always an angle. So what we are in quest of right now, we're in quest of an angle. What thing can get us angles? You did it last night. Last night I kept asking the question and you'd say angles. Today I'm saying angles and I'm looking for the flip side of that fact.
Inverse trig?
Inverses. Inverse trig gets you angles. So if you have to try to get an angle, you're going to have to do inverse. How do you use your machine to do inverse stuff? The second button. So we're going to go, everything in math has an opposite. Back here, the problem had dividing, so you had multiply. This problem has trig, so you have to do inverse trig. It's the opposite, it undoes it. So we would need to do inverse tan, which is the yellow button on your machine, 3/5. Push buttons, it's like, it's 30 points something, 30 and some change. There are very few, if any, in this homework that I can remember that have an X on the bottom. I'm not sure about that. There might be some, but I think that's pretty limited. There are absolutely questions where you have to get an angle. Getting an angle is always going to be an inverse. The majority, though, I think, is X's on top of it.
For the sine 41, what are you putting into the calculator?
10 dividing sine 40.
Okay, thank you.
In one big swoop. Anything about those? We can cut the video.